And welcome back, everybody. I'm going to go ahead and share my screen here. Welcome back to all the folks who've joined us for previous sessions. If you are jumping into the session for the first time, this is part 3 of a series that we've been doing all around evaluating agents. As the team said, my name is John. I am the head of developer relations at Arize. And our whole focus at Arize is around evaluation, observability, monitoring, and helping you build better agents over time. So far in the series, we walked through a bunch of different kind of pieces of agents, how to evaluate them, and we're going to go into some more advanced topics today. So we'll do a little bit of a recap of what you've learned so far, and then we'll go into a couple more advanced areas like agent as a judge and some more advanced evals like trajectory evals and planning and reflection evals as well too. For anyone who hasn't been on one of these before, I definitely like people to drop questions in as you're going through. So if you have any questions as you're going, feel free to drop them in the chat. I'd much rather tackle them as we're going and they're fresh in your mind as opposed to saving them all for the end. So feel free to drop questions in the chat as you go, and I'll take some pauses to answer those as we go through. Right. Oh, it sounds like there's maybe an issue with screen sharing. Uh, I'll reshare and see if that can address what we're running into. Let's try that one more time. Just technical difficulties. Bear with us for 1 second. All right. Okay. That should be in some better shape. Let me know if you guys are still having issues. I'm sorry about
It's
that.
perfect, John. It's perfect.
Okay, cool. Sounds great. All right. Cool. So a little bit of what you've learned so far. We'll do a little bit of a recap, just to kind of keep everybody fresh here. So far, we've had 2 sessions. We've gone through what an AI agent is, as well as some of the techniques that you can use to evaluate those agents. So far, we looked at a little bit of a definition around what an agent is, in this case, using this kind of general one pulled from the Hugging Face team, which is that AI agents are programs where LLM outputs control the workflow. Okay, I see some messages that we're maybe having some more technical issues. DS Dojo team, can you guys see my screen okay?
Yes, it's perfect for us.
Okay. All right. Well, I'll keep going on for now. If you guys
I'll
are,
let you know.
yeah, let me know if there's any issues. Okay. All right. So basic definition of an agent here. Programs where LLM outputs control the workflow to some degree. It's kind of our general definition. You learned about some of the different components of agents, so routers, skills, execution branches, and loops, whatever we want to refer to them there, as well as memory and kind of how each of those different pieces are used to build up agents. And we also looked at a series of different architectures for agents as well in the first session. So we went through a router architecture, more orchestrator architectures, parallelization, evaluator, optimizer, and sequential patterns. So some of the common patterns that people will use to build up agents and kind of compose their agents together. And then in the second session, we looked a little bit more at the different pieces of agents that you can evaluate. So evaluating routers, skills and functions. And then we didn't really talk about the path too much in the previous session. We're going to tackle some more of that today as we look at some more of the advanced eval techniques. And then we finally looked at some different techniques for how you actually run an evaluation. So we learned a little bit more about LLM as a judge. You learned about code-based evals, and then different methods for collecting and using human feedback as you go through. So finally, we looked at how you can put all of these different pieces together to create this loop of continual improvement of agents, utilizing things like experiments, tracing and data collection, evals on your data sets as you go through, augmenting those data sets with failure cases, potentially incorporating some human labeling, and then using those to improve your application from there. So we talked about this virtuous cycle of how you continually improve your agent from both the development and the production side using all of these different tools in concert. Hopefully that's familiar to everybody. That's kind of the things we reviewed in our previous sessions here, just a little bit of a quick run through again there. And then from there, we're going to dive into a couple different topics today. So we're going to go into more advanced evaluations that we see people running. So around trajectory, planning, and reflection evals, and then looking at agent as a judge as a more advanced technique there too. Okay. So for the advanced evals, there's a few different techniques that I want to call out here. I think the important thing to remember is that when it comes to evaluation of agents, there you have LLMs as judge as a technique. And so that really unlocks a lot of different things that you could look at from an eval perspective. You could evaluate many, many different aspects of your application because you're only really limited by the prompt that you could construct. Whether those are good evals and accurate evals is another question. So it's helpful to learn some of these different areas that people focus on. But I don't want you to view this as a comprehensive list. There are other dimensions that you could evaluate in your agent, but these are just some common ones that we see people doing. So we'll look at each of these, but so planning, reflection, and trajectory are all three different ones that we're going to look at. Planning typically involves in some agents, you will have an extra step before you actually go through an act where you'll ask the agent to plan out its path. And so you'll say, here are your available tools or your available skills, and here's the user input. We're going to ask that you plan and generate a plan for how you're going to approach this problem. And that can be useful if you have a more complex issue that you need to decompose, or you need to kind of create a plan for in what the agent's being asked to do. And that plan, when it's generated, is also extremely useful to be able to evaluate. You can think of one way that with this planning, one thing it's doing here is kind of taking a lot of the routing decisions that you would typically handle on kind of a as needed basis with different routing logic in your app, and you're pulling it all to the beginning of your agent. So you're saying, okay, we're going to plan out everything before we go through and we execute on this plan. And that can be helpful. It can also be very helpful for evaluation because it means that you're no longer having to look at individual routing decisions. You're now looking at an overall plan that was generated at the beginning of your application's execution. So depending on what kind of agent you're setting up, especially if your agent is one that doesn't need to dynamically change its trajectory based on outputs that come through midway in the application, so if there's certain tools or things like that that have certain outputs that would maybe change how your agent executes, then planning may not be a good approach for your agent architecture. However, if you can kind of take in an input and decide, okay, based on this input, I know all the different steps I'm going to go through, then planning is helpful for centralizing all of that logic into one place. And then it's also very helpful from an evaluation perspective because you can actually evaluate that singular plan and then make tweaks to that specific planning step as opposed to having to make tweaks to distributed routing logic that might be all throughout your agent as you go through. And then reflection is another kind of eval type that we see. And this is actually very similar if you think all the way back to our evaluator optimizer pattern here, where you have an LLM call or a step in your agent that is then evaluated and sort of critiqued here. The evaluator optimizer step really is using reflection to some degree. It's kind of using it on a very specific singular degree, but it is using this technique of reflection. And so generally what reflection is going to be doing is deciding whether or not to repeat a previous step or previous steps in your application. And so it's an evaluation that you can run either after the fact, but typically you'll run it more during the execution of your agent to decide whether you should return to a previous step, whether you got an incorrect output, or whether you can just get a better output and you want to go back through a previous step or run that you've done. So reflection is another technique that you'll see done to do that. That's typically grouped in the evaluation kind of approach here. And then finally, trajectory is going to be the third technique here. And that is basically looking at the overall path the agent took. So if you think about the routing evals that we learned about last week, those are really good at deciding, okay, at a given moment, does the agent make the right decision on which step to go down? With trajectory, you're looking at after the agent's finished its whole execution, you're looking at all the steps it took and deciding whether or not that is something that is is the optimal path, whether it repeated steps it didn't need to, whether it was inefficient in some way, or it took steps that it didn't need to go down. So these are three different kinds of more what I would call advanced evals that you might run. And you'll see that from a techniques perspective, each of these can be done with an LLM as a judge. I think as we looked at last week, you'll always introduce some amount of uncertainty whenever you use LLM as a judge. So if you can use the other techniques, it's generally a better approach to do it. However, because it's so flexible, it can be used for each of these different approaches. And then with reflection and trajectories, you can often use either code-based or a comparison against ground truth as well there too. So For planning, for example, this is a LLM as a judge template that we have within our ecosystem and within our platform that can be used to evaluate planning using an LLM as a judge. And so a couple things to call out here is that the data that's being taken in is a task. So it's usually an input from a user. So what is the agent being asked to do? What are the available tools that it has that it can use to do that? So what are the different functions it can call or paths it can go down? And then what is the plan that was generated? So again, this is kind of after the plan has been generated, you're taking this template and sort of applying it to the generated plan. And then you're asking it for this criteria. So you're asking whether the plan is valid in itself. It doesn't include made up tools, whether the tools will actually answer the user's question and kind of complete the task that's been assigned to the agent. And then whether the plan will achieve the desired outcome. And then finally, if it's the shortest and most efficient plan to accomplish the task. That's almost getting more towards the trajectory evaluation side. And so that's something that we can also see incorporated into the planning step. Again, this is a powerful kind of eval, but it only works for agents where you are actually having it generate a specific plan before acting from there. So another way to think about this is kind of like an augmented routing eval in a way. All right. And then when it comes to reflection, I think a lot of times the questions that you're asking from a reflection perspective are things that can be sometimes answered in code. And so if you think of the questions that you may ask from a reflection perspective, you might ask if the agent made any sort of error in a previous step, depending on what the error is, what the kind of error it could make. That might be a code-based check that you can make, or it might have to be with an LLM as a judge. Oftentimes, you can also look at things like the format of the outputs. So because you're looking midway through the execution of your agent, you can check whether the outputs from a previous step are formatted as expected, or whether the output is maybe out of the expected distribution range. So if you're having it generate something numeric or classification labels or something like that as part of an intermediate step, you can check to see whether the agent has, or whether that particular step has generated something that's not one of those classification labels, or it's not a number, it should be a number, or it's a number and it shouldn't be a number. So you can kind of look at some of these different formatting steps throughout to try to find your points where you might want to reflect and repeat a previous step to improve. And the fourth one that we have in here is whether the agent chose to use or not use certain tools. So you may also know that for certain kinds of inputs or certain tasks, it's going to be required to use a tool. And so you can bake some of that logic into this reflection step as well too, to say if that tool hasn't been used, then we're going to repeat that previous step to see if it can make an earlier decision. So it's kind of returning back to an earlier point in your application to keep it running. And hopefully a theme that you'll see throughout this whole series is that if you can make the check with code instead of an LLM, then try to do it with code, because that will be deterministic. It will not have the additional uncertainty that comes with an LLM as a judge check as you go through. All right. And then our final one here, trajectory. So from a trajectory standpoint, oftentimes the way that we see trajectory evaluated in the industry is comparing against ground truth. So you'll see this is an example I pulled from actually a Google eval library where they incorporate this technique, and it's one that we have integrated with along with our library to actually run within Arize and Phoenix. And so what you'll see is on the left, the reference trajectory for a particular example. What are the expected tools and parameters as part of that? And then on the right, you'll see the actual trajectory. And so this is what actually happened when we ran the agent and whether it actually made the right call. And so you can see in this case, there are a couple places where even though it's getting the right inputs, it's not, or the right tool names, it's not actually getting the correct inputs. So if you look, for example, this device ID, device 2 here is the expected value, and then device ID, device 3 is the actual one that we're seeing. So you can use these trajectory evals to kind of encompass your routing evals that we looked at last week, as well as the overall trajectory and overall path that's taken. So they're kind of another way of augmenting some of those on top. The downside is that you have to have this actual expected output, this expected trajectory, which you may not have depending on the input. So this is oftentimes something that we see used in more of a development context as you're building your agent, because you can specify certain test cases, you could specify expected trajectories, and then test against those. But then once you get into the wild, you don't actually know all the different inputs that you're going to get. And so you can't really use the same comparison against ground truth method for trajectory and for measuring trajectory. So again, this is kind of a augmented version of some of the routing evals that we looked at previously, but it is somewhat limited in how it can be evaluated and where you have ground truth. Obviously, with trajectory, you can use an LLM as a judge. You can essentially take the actual trajectory, so the box on the right here, and you can compose that into a prompt along with some of the possible tools. And you could ask an LLM to critique that. I think what we found in practice there is that if you do so, then you'll have, if the LLM or if your agent has taken very obviously poor paths, if it's repeated tools with the same inputs, for example, an LLM as a judge can usually find that and sort of track that and call that out. But if it's a bit more of an insidious kind of or hard to detect sort of trajectory mistake, then just a base LLM as a judge is going to have a hard time detecting that. So it can be useful, but it sort of limits you to some of the more obvious errors that are going to come through in that case. So if you think back to previous weeks where we looked at routing evals, we looked at skill evals, and we looked at some of the different techniques that are used there, you can now add these trajectory, reflection, and planning evals to that same kind of locker that you have of different testing techniques. Again, these ones are a little bit more specific to the type of application that you're building. If you don't have a planning step, can't really use the planning eval. If you don't have a reflection step in your agent, you're not going to use the reflection eval. However, almost every agent can use the trajectory, but you're going to be slightly limited in terms of the types of ground truth you can compare against and some of the issues that you can detect with an LLM as a judge. Right. I'm going to pause there because from here we're going to go into a different topic, which is the agent as a judge topic. And so I'll pause in case there's any questions on what we covered so far. All right. Cool. Super clear. Love it. Everybody's got it. Okay. So then from there, we're going to talk about agent as a judge. And this is a technique that we saw in an original paper last year. And I'm going to go through some of that as kind of the basis that you have for it. And it's now something that we've seen incorporated in a few different areas. Now, some of the platforms for evaluation that are in our space are exploring this as a particular route to use, either instead of or to augment LLM as a judge. But the general idea here is that you're constructing some sort of agent that instead of doing individual LLM as a judge calls, can take a more holistic view of your application and of the runs of your run or of your agent there. And then you can apply either individual LLM as a judge calls, you can apply other kinds of calls automatically using this agent as a judge approach. And so I'll go through a little bit of the original kind of paper we saw this mentioned in. This was last October, so in AI terms, that is ancient at this point, but it is still somewhat recent in other terms. And then we'll talk a little bit about how this gets used today. So agent as a judge, this paper was from a team out of Meta, and it introduced this agent as a judge framework on a very specific use case where they were kind of citing this issue that a lot of existing techniques were focused on final outcomes, or they required a lot of manual labor or labeling or kind of manual ground truth data. And so those don't really work in agent contexts. And so I think one way to think about this is there's almost sort of two convergent evolution paths that have happened over the past year or so when it comes to evaluating agents. There's one, which is what we talked about so far, which is all around decomposing the agent into different steps or different tasks that it has to do, constructing specific evals that are good for those sorts of tasks, and then combining all of those results together to give you a picture overall of how your agent is performing, where it's maybe making errors, and kind of breaking down the problem, solutioning each individual piece, and then building that back up to give you the full picture. That's one way, and that's almost more of a manual way, even though we're using AI to do all this stuff. It's kind of more of a manual approach versus something like agent as a judge, where in this case, it's instead of having humans kind of break that down and create all these different evaluation techniques, we're going to create an agent that can just do all that for you, basically. And so that's the other path that has gone down. And again, there's some companies in our space that are more aggressively pursuing that technique. There are some that are kind of going for more the traditional technique. We're kind of doing both to a degree at Arize, so we're exploring both angles, but that is something that we're seeing in our space. And this QR code just leads you to the paper if you want to take a deeper look at it. And so what they did in this particular example was kind of what we've done over the course of this these three different sessions. They break down the actual steps that the agent has to go through. In this case, they're using a coding agent generally here. So you can imagine that this agent as a judge is always being applied to a coding agent. And so they break down some things that the agent might have to do, and they create evaluations or steps almost to evaluate each of those. So they know that this particular coding agent is going to construct different files. It's going to modify folders, access folders. It's going to generate code across multiple files and have to extract kind of different info from those files, ultimately to satisfy some set of requirements. So you can imagine that they're testing this coding agent with a bunch of questions and requirements for those questions. So, for example, generate the code for a Flappy Bird game, and there are requirements of it needs to scroll sideways, it needs to have a sort of animated bird icon, whatever it might be. So you might have requirements that need to be satisfied. And so they break down, they kind of gave the agent as a judge, the judge agent here, tools to be able to evaluate each of these different areas. So they gave it one to kind of graph the whole project and construct kind of an idea of what that particular agent did as it went through and kind of what was the code that it generated. So graphing all of that. Then it gave it a tool, gave the judge a tool to locate some of the different folders and files and things like that that were generated. They also gave it one tool to read the files and understand the data. They gave it tools to search through all of the code that was generated to find relevant snippets. And then they gave it another tool to actually retrieve info from long segments of text. The idea here was that if your coding agent generates 1,000-line file, then you need to be able to retrieve individual info from specific areas of that longer file. And they also gave it tools for just asking whether or not the requirements are satisfied, and tools for memory and planning. So they gave it tools to kind of judge and plan the agent's path. What they found is that not all of these tools were necessary. So a little bit of a fake out here, but what they found is that really the things that mattered for the judge agent to be able to have was the graph, locate, read, retrieve, and ask tool. What they found is they didn't really need the search tool, the memory tool, or the planning tool. With each of those, they removed these tools, kind of did like a suite-based test to figure out which of them were necessary. And so you can see that what they ended up with was basically tools for the judge agent to be able to retrieve all the different files and all the different information in them and ask whether or not the requirements were satisfied, and finally graph the overall structure of the generated project. So they kind of remove some of the extraneous stuff, which is encouraging because it means if you're going to repeat this, then you actually don't need to have a crazy comprehensive specific set of tools. You basically just need to have the tools to be able to give the judge agent all the individual generated pieces of information. So they went through, created this judge agent. What they were able to see is that as they added these different components, so as they gave the judge agent this ask tool and then the graph tool and then the read tool and the locate tool, you can see the performance going up generally over time. So they tried all these different combinations of tools to give the judge. And they found that those were the 5 that are the most important for it. Now, there's quite a bit in this, so we'll talk through some of this. But in this case, don't have to go through all of the results here. They obviously tried a bunch of different techniques, but generally what they found is that the agent as a judge would outperform the LLM as a judge, and basically matched the alignment rate or the correctness rate of making these judgments to a group of human evaluators, which is actually pretty impressive because in this case, they're actually using the kind of combined judgment of 3 different human evaluators to do kind of ground truth labeling in this experiment that they would then compare the agent as a judge to. And so they went through and they would compare against that majority vote from the 3 different humans. And what they found was that the agent as a judge matched that majority vote, and it actually beat out almost every individual human. So one way to think about this is that the agent as a judge outperformed individual people going in and labeling, and it matched the performance of the collective group in that case. And so it had some impressive results. And so that was very cool to see. Again, this was last October, so people have taken steps from there. I think there's a couple things that jump out to me as part of this, though, which is that so far they had to build a very specific agent as a judge to answer this task and to judge this coding generation task. So they had to give it very specific tools. They had to structure it in a specific way. And we often find that that's the case even just with LLM as a judge, where we have this pre-baked set of templates that people can use. But oftentimes we're having to test those and rework those and change those with individual customers that we work with. And so I have a hard time, just personally from my side here, believing that agent as a judge would work in a different way. I think we would need to have the same kind of approach. And this is somewhat of what we're seeing, is that it's very hard to create a general agent as a judge that can evaluate all kinds of different agents that you might build. So you do need to kind of create some specificity for that agent as a judge itself as you go through. So I think that's one thing that comes to mind for me. And we have somewhat seen that play out over the past few months. There are a couple different sort of providers in our space that offer agents as judges. They tend to be specific for certain criteria that they are actually evaluating so far at this point. And so there's a question in the chat about how do you train the agent as a judge with the necessary pattern? So in the paper example here, they actually had it trained on specific examples from a data set that they had generated, if I remember correctly. So they had to actually sort of train and tweak the agent itself as a judge, which is actually what we often do with LLM as a judge, even in our platform. So again, when we're working with customers there, we'll often kind of train and tweak the LLM prompt to match some ground truth data that they might have labeled. And so I think typically within an agent as a judge, if you're trying to make it specific in that way, then you would have to kind of do a similar thing. So you would have some amount of ground truth data potentially for your individual tools, for example. So you might have ground truth data for the execution of the locate tool or things like that. And then from there, you can kind of train the judge based on that information to scale it up from there. And then there's a follow-on question, which is how does it prevent hallucinations? So similar kind of thing by training that agent on some existing ground truth data, then you would kind of build it up from there, and you would maybe not remove all of the potential for mistakes, but you would at least understand how closely your agent as a judge aligns to human labels. And that's kind of what they're reporting on here in the end of the paper. They're going through the alignment rate between the agent as a judge and then the majority vote of humans. So one thing to call out too is that you see even the majority vote has this 95% alignment rate. That is because they then have kind of the creators of the data set, the experts in this case, actually having the ground truth labeled example there versus these individual humans who are making the judgment. So I think it's always funny with these examples because correctness is to some degree still subjective. So this is in this case just at least using the creators of the data set they tested with as the alignment rate or as the ground truth there. So yes, whenever you're building one of these systems, it's hard to avoid it coming down to some amount of ground truth data or labeled data. And typically the pattern, whether you're doing LLM as a judge or agent as a judge, is that you start from that ground truth labeled data, and then you can build up either an LLM as a judge or an agent as a judge to replicate your own judgment as represented by that ground truth data. So you can replicate, you can get the agent to be very good at replicating those judgments you're making and then scale it up from there. So now you don't have to do human review across all of these different patterns. And then there's another question, which is, can we create a custom agent as a judge? So definitely that would be kind of how you would go through that process. And then can we integrate with MCP or A2A? That is definitely a way that you could incorporate an agent as a judge. So if you were to create a custom agent as a judge, then you could set up that agent as a judge to connect with different platforms through A2A, so through agent to agent, Google's framework, or using MCP if you wanted to make the agent service in that way. I think, again, the thing that we run into oftentimes, though, is that it's not a one size fits all for agent as a judge. If you create an agent as a judge, it's not going to work across all different kinds of agents that you want it to judge. You'd have to do some tweaking on specific areas there. And that's an area that we are definitely doing our own kind of deep diving into as well as we go. So, awesome. Oh, and then there's a question around, great, thanks. How do we monitor it? Can Arize help us? So yes, we definitely can. And that is something that we can do within the platform. And we have a good bit of time left. So I'm actually going to just jump into some of the platform and I'll show you guys some of what that looks like because we have a little bit of time. So I'm going to go slightly off script here and show you some of those pieces. And so in previous rounds, we had looked at some of the examples within the Arize dashboard around how we do this. And there's really quick before I keep going, there's a question around access and reporting. We will have a recording for this. I'll let the DS Dojo folks jump in there and share and talk about how we'll share the recording. So within the Arize platform that we have here, we've talked about ways of kind of tracing agents. And I think the thing that's important to know here is that all of the stuff that we have learned about for how you evaluate agents so far with these different techniques can be applied to your agent as a judge. So if you're going to build an agent as a judge, then you can actually apply all the same techniques that we just learned about to evaluate your other agents through your judge agent. At the end of the day, the judge agent is just another kind of agent. And so you can apply all these techniques that we used to that specific agent. So for example, you might have a example agent that you're tracing that is a particular judge agent, and you can capture traces on it from here. And then you can add in different metrics. Like we may, for example, we'll add one just for fun here. We may add a particular eval to our judge agent, for example. So if we had a judge agent, we could add an evaluation for the, we'll say judge agent correctness. And so we could do this, say we had an example agent judge that we were using, and we could apply either an LLM eval or a code-based eval to judge that agent's correctness. So we might have an LLM eval, for example, where we create our own specific prompt around, I'll do a base example here, or, let's do this. We'll do a base example here of, so we could use an LLM as a judge to evaluate our agent judge's correctness. We're getting very meta at this point. We could go for that approach and build our own template around that. And so we could apply that within our agent judge. Or we could actually do a comparison against ground truth. Say we had a ground truth set of labeled data. We could run our agent judge over a couple different examples to actually have it test and compare against that ground truth. And then from there, we could create our tasks. We could create different metrics that we want to do. And eventually we could build up our own dashboards that show things like the agent as a judge correctness on a sort of month time frame. Or, and we'll expand this back further. So we can look at our agent as a judge correctness over time, kind of graphed through the same tools that we looked at in previous sessions to actually measure the agent's performance generally. So there's all the techniques that we've used so far could be applied to your agent as a judge. Folks have ever heard the famous quote around "it's turtled all the way down" in terms of what is holding up the earth. Someone says it's on the back of a turtle, and then someone says, "What's that turtle standing on?" And they say another turtle. And they go, "What's that turtle standing on?" And the guy says, "It's turtles all the way down." To a degree, where it's kind of where we're getting to with this. We're using agents to judge agents, and then we're using these existing evaluation techniques that we have gone through to actually create the agent judge. But really, instead of turtles all the way down, we have a base level of some amount of human level labeled data that we're creating to use as that ground truth. Okay. And I think that's really the majority of what I have for you guys today in our final session here. So, a little bit of wrap up. We've talked through a lot of different topics so far in these sessions. We've talked through what an AI agent is. We've talked through some of the techniques around evaluating those agents. And then today we talked about kind of a quick kind of primer for some more advanced topics of things that we're seeing in the space now, some of those more advanced evaluation techniques or evaluation metrics that we're looking at. And then looking into agent as a judge and kind of this new technique that we're seeing some people adopt across the industry and how that might be applied for specific examples there. And so that's the bulk of what I have for you guys today. So shorter session to cap us off, but happy to hang out, answer any other questions that folks have, dive into anything that we've gone through in all of these sessions so far, if anyone's curious for more information on any of those pieces. And I do see there's a question around can we share the deck? Yep, we can share the deck. So we will have that shared along with the other materials as well.
If anyone has any questions, they can ask it right now.
Mhm. And yes, Desert Team, we can share the first session
Yes,
slides and
we
things
can
like that
definitely
too.
share the
Yeah,
first session slide as well.
awesome. Yeah, I would highly
Uh,
recommend going through previous sessions if you can, just because it ideally tells you kind of a story across the three different ones.
After the webinar, we will share the access for to the past recordings as well, so that you can go to them and check them out. Definitely.
I'll say. And there was a question around whether I could show the full slide for sequential architecture. So let me pull up. I think that was from our first session. I can pull up the full slide there. There's a question of can we show the sequential architecture? So this is kind of reverting back to a previous session that we've gone through. This was one of the patterns by which you could sort of organize either part of an agent or a full agent here. And so this would be kind of very basic sequential or prompt chaining architecture here, where you could go through different LLM calls that can make kind of fork decisions. This is almost like a directed acyclic graph would be one other way to think about this. Typically, you'll have this approach in kind of the more basic of something that may even just be an agent, kind of fudging the definition a little bit there. But oftentimes you'll see this as the structure for a skill within an agent. So you might have something like a routing architecture that then leads to these sequential prompt chains as part of the skill of the agent. Very much. Let me know if there's anything specific you were wondering about there as well, too. Right. And then there was a question around difference between data science and or data engineering and AI agents, and how those are similar in the sense that they're automating tasks, but what's the major difference between the two? I think that there's a large difference in some of the work that you would do in the different spaces to create these different techniques. I think as much as we talked about grounding AI agents in human ground truth and kind of human labeled data, I think that oftentimes once you have that in place, you're then tweaking a lot of things like prompts or some of the other kind of fuzzier types of decision points to actually improve your agents over time. So versus something like data engineering, you can have much more of this deterministic kind of approach to things where if you know what the outputs of specific calls should be or specific queries, you can kind of have deterministic certainty around the different steps of your application. When it comes to agents, even though you're basing it in ground truth a lot of times, then there's going to be issues where you have decision points that are being made by LLMs, which then introduces this non-deterministic element. And so then it's much harder to evaluate, which leads us to a lot of the techniques that we've talked about over the course of this series around how we can actually do that. All right, and I'm also just going to drop, there's a couple of requests for slides. So I'm just going to drop the slides link in here for anyone who wants them as we go. So I'll drop that and I think we'll share them after the fact too. All right. Awesome. And then there was a question around in the function calling architecture, like the routing architecture, which tell you what, let me go back to our, there's a lot of questions we're getting around the architecture review slide. So I'll just pull that up. So in kind of one of these routing architectures or orchestration architectures, there was a question around using the LLM as a judge, using the tools and eval beforehand. So I think if I'm understanding your question correctly, it's around whether you could use an LLM as a judge to evaluate the success of that routing call, and whether you could actually do that beforehand. So maybe as your agent's running, for example, you could do kind of a reflection step almost at that point. So yes, you could do both those things. I think evaluating that routing step using an LLM as a judge is one of the more common evals that we see for agents. So whether you're doing that kind of after the fact, going back to measure the success rate of that routing step, that is something that people definitely do and will do with an LLM as a judge. I think LLMs as judges can actually do pretty well with those types of tasks because you have a preset list of options across the different tools, and then you also have a existing description of when those tools should be used. So that gives your judge quite a lot of information to go off of to evaluate those potential calls. So we definitely see that being used. You could do a reflection step there to say before actually routing down that specific path, having another LLM check and reflect and see if that was the right call to be made. I think the only concern there is you're adding additional latency to those calls. So if it's a user-facing application, you're adding another LLM call as part of the main thread. And then from a cost perspective, you're also adding another LLM call as part of every one of the rounds of your router. So we typically see people doing it more after the fact and kind of applying those from there. But say you had an application that wasn't user-facing, say maybe you were using local LLMs or your own hosted LLMs, that was going to reduce your cost, or you were just using very small models, then you could use that kind of approach as well too. And there is a template that we have in Arize and in Phoenix around evaluating the LLM as a judge, or sorry, evaluating the routing step. So if I can remember where these are, hold on. We have a set of pre-built evals for what we call function calling in this case, which is really the main way that we see people doing a lot of those judgments. So you can see a template that we will work with here. And so you can get an idea of the user question and then the chosen tool, as well as the definition of all of those different tools. And so we do have this kind of pre-built LLM as a judge template for that. Right. Well, if there's any more questions, again, feel free to drop them in. And then also just a big thank you to everybody for joining for these different sessions as we've gone through some of these techniques. Hopefully this was a good kind of introduction to some of these areas for everybody. If you have any questions after the fact, then feel free to reach out on any of the socials that I have linked here. We also have our own community, or you can reach out through the Data Science Dojo community as well too. And one other thing I'll just do as a quick plug on the left side is that we actually just updated some features in our Arize platform to kind of enable real-time ingestion of traces across all of the accounts that are using us. So if you haven't had a chance to play with Arize yet, now is kind of a great time to try that out. So I would recommend checking it out. You can create an account for free and start playing with it and start seeing some of these techniques that we used in practice out in the real world.
Thank you, John, for